Rectification means converting alternating current, which we have here, to direct current. So AC to DC is what we're going to do. So the first circuit we're going to look at is a half-wave rectifier. And before we do anything, here we have a transformer. Let's just consider what the supply looks like on the secondary of that transformer. So your supply is basically going to look like this. So this is AC, and that's what we get at this point. So if we then bring in the circuit that's going to do the rectification, a single diode on its own can be called a rectifier, and in this circuit we're going to use it to rectify the AC supply so that our load just receives DC. So this is the load, and I've used a resistor, but it could be anything at all. It could be a mobile phone charger, for example, but we'll just draw it as a resistor. That's the load that we're going to supply. And here I have a diode. So let's consider what's going to happen. On the first half cycle of the supply, which is this is our first half cycle. This is positive and this is negative. That's what this supply is doing. That means a current will go through that diode, through the load, and back to this end of the supply. So the current is going through the load for that half cycle. Let's draw the current through the load. This is the current through the load, and that is now going to do something like that. A bit untidy, but this should be the same shape as that. If we then consider the next half cycle of the supply, which is this, and that's available here, the polarity changes. So this end is positive and this end is negative. If we look at what is happening now, this diode is in reverse bias, so it blocks the flow of current. So no current can flow on the next half cycle. So we have nothing. This is our AC supply carrying on and on and on, and the next positive half cycle arrives and we get back to this situation and the current flows through the load again. So we then have current flowing through the load. So this process will repeat on and on. This is called half-wave rectification because the load only receives half of the available current through it. So, quick summary, the current that goes through the load is going to go on, off, on, off, on, and it will carry on doing that. This is not a lot of use for most circuits. An extremely poor, low-quality circuit could make use of it. So let's look at an improvement on that. The bridge rectifier is probably the most popular rectification method in the world today. And here we have our AC supply. There we have. So there's AC. There's the primary of the transformer. This is the secondary. So we usually step down to a usable voltage. And at this point, we still have AC. So from there to there we have AC. Let me draw that in. That'll do. So this is the available current at this point on the secondary. If we then connect our circuit that's going to do the rectification and we connect the load in, it'll look something like this. Oops. So we've got 4 diodes. Quickly label them up. I'm going to call this D1, D2, D3 and D4. So the load in our circuit is going to connect between these 2 points. I'll draw it as a resistor, like so. Remember, the aim of this is to get the current that goes through our load to be DC, direct current, only flowing through it in one direction. So let's consider the operation of this. Here is the current which is delivered to this point here, so let's consider it 1/2 cycle at a time. So on the first half cycle, the polarity is this is positive and this is negative. Current wants to go positive to negative. The current will flow to this point. It will not flow down here because D4 is blocking. It will flow through D1. It will not flow down here because D2 is blocking, and it will flow through the load. So if it's going in there, that makes this end of the load plus. So at this point, it doesn't want to go positive to positive. The current wants to go positive to negative, so it's not going to come down here. It's going to go down here and back along here. So that is the first half cycle of the supply. It's going to go through that route. So the current that is delivered to the load now looks like this. So that is the same shape as that. If we then consider the next half cycle, so we're into this half cycle, the negative half cycle, the polarity has changed. This is positive and this is negative. The current will flow from here, that is blocking. It will go through this one. That is blocking, so the current will go this way through the load. So it's the same direction as the first half cycle. This end is positive. The current won't go down here, it'll go up through D4 and back over here. So on the next half cycle, the current will do this. The next half cycle reverts back to the red one here, the first half cycle, and we'll get that, and on it goes. So this is all positive. We are now sending DC, direct current, through the load. It is all in one direction, which is what we're trying to achieve. The reality is this is very lumpy, very uneven. We say it has ripple, and that's not very useful for a lot of circuits. So in the next video, I'll look at how to remedy that. So here is a plug-in power supply. This is used to feed the speakers, which are with my PC. So I'm sure you know the arrangement. Plug this into your 230 volt socket, and the output from this is 6 volts DC, and that supplies the speakers. So inside that particular casing is something that will look just like this or very similar. And what we have is a transformer and a bridge rectifier with a smoothing capacitor. So here is the transformer. Here we go. I don't know if you can make out the laminations. You can see the size of it compared to my hand. This is tiny. Here are 4 diodes which are mounted vertically, simply to save space. And here is a smoothing capacitor, and the capacitor is used to take the ripple out of the supply.